Hello, honors algebra students. Mr. Laurence here, and I heard a rumor that Sean heard a rumor on the internet that there was a type of mixture problem using distance, rate, and time that was really difficult. And I told you, Sean, you can't believe everything you hear on the internet. Trust me, these problems are simple. We're going to try some of these problems. Before we do, I do want to mention Mrs. Blasek told me that you guys are having problems with this in science, and I think they put a triangle around it. Now, I don't personally like setting my problems up like this, but hopefully she wasn't talking about any of you, because this is just a distance equals rate times time. Hopefully what you're doing in science, at least in Mrs. Blake's class, should be super duper simple. We're going to be using this distance equals rate times time in just a minute. Anyway, let's check out this problem here. Sean is riding his bike against the wind. It takes him 3 hours to travel 24 miles. The return trip only takes him 2 hours because the wind is at his back. What are the speeds of Sean and the wind? Well, let's see what's going on here. First of all, we need Sean on his bicycle. Okay. So there's his bike, and then here's Sean. Right? And he's riding along, you know, but what he finds is that when the wind is blowing towards him, I'm sure you've ridden your bicycle in the wind, he has a much harder time. The wind works against him and slows. Oh, fiddle faddle. The wind works against him. The drawing works against Mr. Laurence. Oh, wow, looks like Sean's eating his handlebars. The wind works against him and slows him down, right? However, when he comes back the same way, now the wind is working against him and it speeds him up. So we're going to write two equations and solve this as a system. Systems may use anything that solve to anything that flows. Well, wind certainly flows. So first of all, we need the speed of Sean. And we need the speed of the wind, right? Now, when Sean is taking 3 hours to go 24 miles, the wind is in his face. How do I know? Because it takes him longer to get there. So the wind will be taking away from Sean's speed. Now, the return trip will be Sean being aided by the wind. Now, before you go fill out what's over on the right-hand side of the equal sign, what is this? It's not Sean, it's Sean's speed or rate. What's this? This is the wind speed. It's not the wind, it's the wind speed or rate. If I think about distance equals speed times time, and I solve for s, I know speed equals the distance divided by the time. So you have to take half a second here and think. I have a speed minus a speed. I must end up with a speed. Then I have a speed plus a speed. I must end up with a speed. There's no other option. So what am I going to put over on the right-hand side? Well, what's the distance? The distance is 24 miles, right? 24 miles. What's the time? 3 hours. This is a speed. Yeah, it's 8 miles per hour, right? Down here, what's the distance? It's the same, 24 miles. What's the time? It's only 2 hours. Excuse me. So, see how simple this is? This is S minus W equals 8, and S plus W equals 12. It looks like a system. It looks like I want to solve this system using elimination. I'm going to add them together. I'm going to get 2S. Those cancel, equaling 20. So therefore, divide by 2. Sean's speed must be 20. Oh, excuse me, not 20. 10 miles per hour. Yeah, Sean's speed is 10 miles per hour. Well, now to get the wind speed, I can just take 10 plus W equals 12 and solve for W. W will equal 2 miles per hour. So Sean's riding along at 10 miles per hour. The wind's blowing at 2 miles per hour. When it's in his face, it slows down Sean down by 2 miles, making him only seem like he's going 8 miles per hour. But he's doing the work to go 10 miles per hour. When it's at his back, he's doing the work to go 10 miles per hour, but he's getting a little boost from the wind, so it's like he's doing the work for 12 miles per hour. That's why he perceives it to be an easier time. All right, let's try another one here. Traveling downstream, a boat goes 5 miles in 45 minutes. I don't like this. I'll talk about it in a second. The return trip takes 75 minutes. What are the speeds of the boat in the river? Well, I don't like this because we normally don't measure things in miles per minute. We usually do miles per hour. We might do feet per second or something, but not miles per minute. So I'm going to convert this to hours. 45 minutes would be 3/4 of an hour, right? Say 45 over 60 equals X over 1 hour, right? I could solve it, simplify it like that. There's a lot of different ways to do it. That's just one way. All right, 75 minutes, that'd be an hour and 15 minutes. Well, that would be 5/4 of an hour, right? Or if you wanted to use that, you could. All right, over here you could use 75 hundredths. Okay, so let's see. We've got a boat traveling downstream. So let's see here. We need some water. So this will be downstream. Here comes my water. Okay, and it's flowing this way. Water always flows downstream, right? Okay, now I need a boat. All right, here's my boat. Ooh, it's a fancy one. And so when it's going downstream, it's going quicker. Whoa, that's crazy. I don't know why. I'm just having boat troubles here. Okay, so when it's flowing downstream, it's going to go a lot faster. Notice the trip only takes 45 minutes. But when it's going upstream, it's going to take much longer, right? An extra half an hour to be precise. Let's see if we can write our two equations. Well, we're going to need the speed of the boat, and we're going to need the speed of the current, or the river current. We can put R, I like the current. Okay, now when he's going downstream, the current is aiding him. When he's going upstream, the current is hindering, taking away from his speed. Okay, so we've got boat speed plus current speed. We need a speed over here. How do we get speed? Speed equals distance divided by time. So what's the distance? 5 miles. What's the time? Well, I'm going to use 0.75. Okay, over here the distance is 5 miles and the time is 1 1/4. Now I can figure out what those are to make my math a little bit easier. So I'm going to have B plus C is going to equal 5 divided by 0.75, and that's going to be 6 2/3. 6 2/3. I'm not going to go with 6.7. Okay, it's not very accurate. All right, the B minus C is going to equal 5 divided by 4 on the nose. I like that. So if I add these together, the currents cancel out because one's positive and one's negative. I'll get 2B, which will equal 10 2/3. Now, if I divide each side by 2, geez, do you think it's going to be 5 1/3? 10 2/3 cut evenly in half? I'll bet it will. So the boat speed will be 5 1/3 miles per hour. The current then, let's see where we at here. I could go 5 1/3 plus C equals 6 2/3. Subtract 5 1/3 from both sides, and I'll get the current is equal to 1 1/3 miles per hour. So the current is not very fast, 1 1/3 miles per hour. There you go. That's it. The only thing you have to keep in mind is to get this number over here, you have to do the distance divided by the time. Why distance divided by time? Because that's the same as rate or speed. That's all it is. Boat speed plus current speed equals the average speed, and boat speed minus current speed equals the average speed. All right, there you go. Mr. Lawrence signing off. Have a good night, everybody.